Hello world, welcome to today's video. So today what we are trying to solve is something called as ROT13, which means rotational cipher 13. So ROT13 is a simple letter substitution cipher that replaces a letter with the letter 13 letters after it. So let's not just confuse ourselves over here. So in yesterday's video, you saw that I solved Caesar cipher, right? So basically they gave you a shift as a number, and then you need to replace that letter by how many ever number that they gave, right? So either you have to go forward for encoding or you have to travel backward for decoding, correct? So rotational cipher is the similar way, only that our shift number is fixed. That is, it's always going to be 13. Now, if you have no idea about what I'm trying to say, just go back to the previous video and check Caesar cipher out so that you will understand what I'm trying to say, right? So our shift key in ROT13 is always 13, right? So given an alphabet, you'll always replace it by 13 extra letters, right? So create a function that takes a string and returns the string ciphered with ROT13. If there are numbers or special characters included in the string, they should be returned as they are, right? So only letters from the Latin English alphabet should be shifted, like in the original ROT13 implementation. So this is going to be very simple for us. So what we are going to do is, when we get our message, let's say our cipher is empty for now, and for I equal to 0, I less than, and let's say let I is equal to 0, message dot length I plus plus, correct? And then what we need to do now is get the character code of our message. So character code at I, and then this has to be of message dot character code at I. Now let us have something called as, what did we call our variable yesterday? New character code, right? Code plus I plus 13 will be our character code for today. New character, sorry if you see that message, new character code equal to so and so, correct? And then what we need to do is replace this message, whatever character is there, with that, right? So let us quickly open our ASCII to character. So result is equal to string dot from character code and 65. So whatever is there, we say string dot from character code and new character code. So this will be our cipher plus equal to, correct? What is wrong over here? I'm just going to call this cipher because that, okay. But why is this not taking, okay, because I have spelled it wrong, right? It's good to have color code. So cipher is equal to so and so from character code. Let's just run this. I'm pretty sure obviously this is going to turn out to be wrong. I'll tell you why. Return cipher. One of the reasons is we are not really seeing if our character, like whatever new character we are getting, if it lies between the alphabetic code or not, like the ASCII code or not, right? And also one more thing we need to do is we need to convert everything into a, do we need to convert it into an uppercase? Let's not do that. And probably let's just say this and let us just test it out, right? So what did we get? We got only R and expected output Y. Why was this the case? Let's just console log our cipher and test it out. We get R. No, that is wrong. Correct. That is completely wrong. Something is not correct. Why is it coming like this? Let's just say let new character, and then we say, I'm not sure, this should not work, right? Cipher plus equal to new character. How, why is this not working? Is it problem with our new character? New character code. It's probably going above the ASCII values, right? That should not be the case. So let's just quickly check out our ASCII table. Which was the one we saw? Was it this? Yes, this was it. So if it goes above this, obviously, no, we don't want that. So maximum it can go is up to 90. So our character's life from 97 to 122. Let's just write that down over here, right? So A is 97 and Z is 122, correct? Is that it? 122. And for uppercase, it's 65 and 90. Uppercase, it's 65 and Z is 90. So when we say this, if it goes higher, right? So if new character code is greater than 122, then what we need to do? If it goes higher than whatever that is, the new character code minus 122, new character code minus 122, and we get something else, and then we say new character code equal to plus equal to 120. It's 97, so we say 96, correct? So this should work out for our first test case, right? What did we get? We got, okay, this is for our second test case, correct? So that is that. Also, what we need to do is if new character code is less than, it should be less than our 97 because it should not be a small letter, and new character code is greater than our 90. If this is the case, then what we need to do is the same thing which we did over here, but we will be doing plus or minus 90 and we'll be doing 64, correct? And then we'll say else if. Let's just check this out now. What did we get? Actual output, expected output, so and so, actual output, we got that. All right. So if it is G, why are we getting? Let's go to G. Where is our G? G is over here, correct? Plus 13 is 71, 81, 82, 83, 84, right? T. Why are we not getting that? Okay, let's just say console.log new character code. We get 97 for, no, hold on. For this G, right? It should be 71. So 71 plus 13, we should get 81, 1, 2, 3, which is T, right? So we need to get 80 something. But why are we getting 97?
One eternity later.
Or we can do one thing. So if character code is greater than 65 and new character code is lesser than 91, greater than 64 and lesser than 91, then we say this over here, and also if new character code is greater than 96 and new character code is lesser than what, 122, is it 122? Then we do this, else if new character code is simply greater than, what is the last one, 122. So if it is greater than 122, then we say new character code minus 122, right? So minus equal to 122, and then new character code plus 96, right? Plus equal to 96, and then we say so and so, correct? So that is for if it is greater than 122. That covered our small letter, right? So let's just test our first case and see if it runs. Yes, our first case still runs, correct? Now for our second case, it's for G, correct? So if it goes above 90, so else if we have to put this before this, right? Else if new character code is, first of all, it should be greater than 90, is greater than 90, and it is lesser than, should be lesser than 97, right? If this is the case, then we say the same thing over here, but we are going to change these values. Now the last value over here for Z is 90, less than equal to 90, I mean minus, correct? And then over here we need to say the first one minus whatever that is and new character. I think this should work. No, it's still not working. Why? Why is it taking A? Okay, let's just run this real quick. Expected output GRFG.
2,000 years later.
Input test and expected output. Oh, this is our input, and from that time I'm reading this as my input. Hold on. So for if it is test, then let's go to T, which is 84, right? So T, then plus 13 will be 94 plus 1, 2, 3. Ah, now I see the problem. Now I see the problem. So what we need to do is we need, instead of this, we need to say message dot character code at I, and over here we need to say message dot character code at I. So if it is a bigger letter, then enter this loop, correct? And for this, if it is a smaller letter, a lowercase letter, character code at I, and here we need to say message dot character code at I. If it is a uppercase, enter this loop, right? But before doing all of that, we need to check, correct? We need to perform a check saying that for this should be the case, right? This if needs to go here if it is greater than so and so, and if it is lesser than. So if it, all we need is if it goes above 90, correct? If it goes above 90, do that. This is that and that is that, good. And let's remove this. And if it goes above something, do this for our 96, correct? So let's just run this test and see. Character code is not a function where 11th line somewhere over here. Message dot character code at I is not a function. What? Why is it not a function? Because it works over here. Why does not it work over here? That is so weird. I mean, probably there needs to be some reason, right? Message code, and we'll say message code. And even somewhere over here we'll say message code. Over here we'll say message code. Probably now it should work. Message code is not a function. Why is it expecting a function? Not this. Yeah, now it should most likely work. Expected output so and so, and what did we get as actual output? We got double of whatever was there, right? So we need an else over here. Else do this. If that is the case, do that. Else do this. Was this supposed to be the case? Yes, finally, all of these work. Now, one more challenge. If you notice in our question, it says, if there are numbers or special characters included in the string, then they should be returned as it is. Now, if it lies between this, it will enter this entire loop. If it lies between this, it will enter this entire loop. Or else what you need to do is else just say cipher plus equal to message dot I, right? Message of I. That's all. Like, don't do anything. Message is not a function. Message is a string. So we need to say character message dot character at I. Just add that. What is the problem? We'll run our initial test first to see if this actually works. So the initial test does not work. Or we'll say else if our message code, right? Or is it our character code? No, it is our message code. Else if message code does not lie between that and that. So it should be greater than 122, less than 122, is it? Should be less than 123, right? It can be 122. 123. Okay, so if it is greater than 122 and message code is also less than 65 and message code is greater than 65 and then 90, correct? It can be 90, but it should not be. And message code is less than our 97, I guess, because it can be 96. Can it be 96? Yes, it can be 96. So if this is the case, then do that. This should probably work and we'll attempt it. Okay, input Ruby is cool. Expected output so and so. What did we get? We did not get our blank space, right? Why did we not get our blank space? Where is our space? Space is 32. This should not be and, right? It should be or. And this should be single. I mean, this was pretty stupid logic that I wrote. Let's just test it out. What am I doing wrong? Why do we have a T? Why do we have a T? Hold on. So let I is equal to 0, I less than message dot length, I plus plus, all right. Message code is equal to message dot character code at I, okay. And then first we see, you know what, we'll do this first. All right, if that is the case, if message dot character code is already so and so, just do that. Else do this entire thing, correct? Now we'll see if this works out for our first test case. No. Actual output test. Why? message code is okay. So we need to do proper, what do you say? Okay, I know a thing. If it does not lie between 97 and 122, correct? So if message code is not, right? So first let's see 97 and 122. So it should be greater than 96 and message code should be lesser than 123. So this one or, correct? Or message code should be greater than 64 and message code should be lesser than 91, correct? And this entire thing is a not operator. Now this should work. We are still not getting that to work. Why? Expected output G and actual output we got this. Why? Because it's entering this. If message code is greater than, if it does not lie between this, or if it does not lie between this. So it does not lie between this, so do this. There is a problem. If it does not lie between that and it does not lie between that, then do that. Still not working out. Why? Hold on, it's not doing the entire thing. Yes, because the not operator was not applying for the entire thing, right? This should work. Yes, finally. I mean, it was my bad. I did not write the pseudocode right. It was more or less like improvisation, kept trying things, right? Never do that because it's going to take long for unnecessary reasons. If you write the pseudocode, it's pretty easy. I have told this before as well on my channel, but I failed to do it. From next time, we'll make a point that without pseudocode, we'll not go further, right? So hopefully you enjoyed it. Let's just submit this and see what other people have done. I'm pretty sure it's easier and also they would have done it in a clever way, right? Let's just see that. Look at this. I mean, I wrote such long sentences for this, right? So basically for every character, if you encounter this, you put this. If you encounter this, you put this. If you do not encounter anything that is in this set, then all you need to do is just have that message right there, just like that, right? And again, the same thing. What I did was very elaborate, and yeah, that was also one of the ways that you can solve. I mean, in programming, this is the thing, man. Like you can solve a given problem in different ways. It's all about efficiency, the time, and the, you know, it should be pretty self-explanatory is what I would like to say. If somebody else is going to read your code, then it should be pretty self-explanatory. Like this is what he's trying to do and this is what is happening, right? I mean, I complicated my problem for no reason. We could have done it using regex, but it's fine. We solved the problem and that's our goal. So hopefully you enjoyed that and I'll see you in the next video.